do. But
Okay.
can we start with the basics, the hard questions? Who are you and what do you do?
So my name is Simon Wardley. What do I do? Gosh. Well, I used to run companies and I used to build companies, and I have a bit of an engineering background. And actually, before that, a background in biology and genetic engineering. And I sort of got into mapping. I'm really interested in the concept of how you map political, economic, social, technological spaces. And I started doing that for myself, my own company, and because I thought this was the sort of stuff you learnt on MBAs, and I'd never done an MBA, so I had to invent my cheap and cheerful way of doing it. And after many, many years of showing other people my cheap and cheerful way of doing it, because I made it all Creative Commons, more and more people picked it up. Then I discovered you didn't learn how to do this stuff at MBAs. And so these days I teach organizations all over the world, and I even teach at a few business schools here and there. How do you understand the landscape you're competing in? So that's what I do, is mapping everything about territory.
I love it. I'm a big fan. So I just spent a year mapping the landscape for Bloomberg
Oh,
media.
gosh.
And so this included all the different, I would call them tribes, but also the industry. So let's start with the basics of what does landscape mapping mean? What's a Wardley map? Why do we do it?
What is a Wardley map? Okay. Well, first of all, most things that we call a map in business, and this is what I discovered: systems maps, mind maps, all those sorts of things, have one property in common. And you can see it by, if you take a map, like a mind map, and you move a piece, but keep the connections the same. So the nodes and the connections, you keep the same, you just move it slightly up or down, or it doesn't change the meaning of it, which is different from a territorial map. Because if you take a territorial map and you, I don't know, take England and move it next to the United States, that does change the meaning of that map. But it didn't change the meaning of these maps. And so the property they all had in common was that none of them were actually maps. They're all graphs. So all these diagrams which have nodes and connections between them, and that doesn't mean they're not useful, but they're not actually mapping a landscape. So the distinction between a map and a graph is that in a map, the space itself has meaning because you're mapping a landscape. You're mapping position of things on a landscape itself. And so this was the problem that I faced 20 years ago exactly. Well, give or take a few months. How do I understand that landscape? Not a territorial one, because we're good at that. We know how to do that. But an economic one, or a technological one, or a social one, or a political one. How do I map that landscape? How do I create some sort of way of giving space meaning in a visualization of that space? And it took me about a year and lots of experiments and lots of failures and then lots of accidents. And the simple way of doing it is I start off by thinking about the anchor, like the magnetic north. And in the case of a Wardley map, that's who are the users. You could have customers, you could have the business, you could have shareholders, you could have regulators. There could be lots of different users, anchors, and that's perfectly fine. So we put the anchors down, and then what? Well, the next question we have to ask is, what do they need? So, the business, if it's a tea shop, might want to sell cups of tea. The consumers might want to drink cups of tea. So we've got now a cup of tea linked, and we've got business and consumers linked to it. Fantastic. But a cup of tea has needs. It needs a cup, it needs tea, it needs hot water, and hot water needs cold water and power, kettle. And a kettle needs power. So now what I've got is anchors at the top and a chain of needs. And we call that, within an organization, a value chain, and across organizations, a supply chain. So that gives me a graph. Now, how do I turn that into a map? Well, it turns out all the components are forms of capital. And capital evolves through a common set of patterns. We start with the genesis of novel and new items, the first time we've ever done something, the first ever radio, we call that genesis. And then we get custom built examples, like custom built radios, the first radio, well, not the first radios, but your own crystal radio set. And then eventually, through supply and demand competition, we get products appearing and rental services, and eventually it becomes so widespread and so well defined, it becomes a commodity, and we get utility services. So what I do is I simply go through my graph. Each component, like a cup of tea, what's a cup of tea? Well, that's a commodity. What about a cup? Well, that's a commodity. What about hot water? That's a commodity. What about kettle? That's a commodity. Power's a commodity. And simply ask the question how evolved that component is. And that generates a map. And from that map, you can then start asking questions like if you're running a tea shop and you're using custom built kettles, you might go, why are we using custom built kettles? Okay, well, surely we should be using a commodity. If all your components are commodity, you might ask yourself, well, how do we differentiate on the left-hand side of the map? What is the sort of novel new things we should be trying to create? Maybe new experiences, maybe we're missing components. So we may be missing staff and a payment system and other things. So we have to extend that on the map. And then we may try and invent something different about our tea shop. And what a map is, it fundamentally is, rather than some perfect representation of a space, because all maps by default have to be imperfect to be useful. And to some, you understand this in territorial, because if you take a map of a city, which city are you in at the moment?
I'm New York City.
New York, right. Well, a perfect map of New York would be 1-to-1 scale, which means it's the size of New York. So if you carry around that in your pocket, a map that you open up, it's the size of New York, that's completely useless. So all maps are imperfect representations of a space, but they enable us to communicate and talk about the space and talk about where things are and how things should change. And for me, this was quite dramatic, because I hadn't realized until I started to use maps that organizations tend to be run by stories. And we tell everybody that great leaders are great storytellers. And so when you challenge somebody's story, you're actually challenging their leadership ability, so that people get very defensive. So if you can get the story on a map, I can challenge the map. So I can say, I think the map is wrong, without saying the person is wrong. And this is actually how you can get groups often in conflict with each other, communicating over a space around a map. So the simple way of creating a map, very easy. Think about the users, think about the user needs, understand the chain of components that make up those needs, and then simply think about how evolved each of those components are. And that's it.
I love it. I love mapping just in general. I'm a big map person, but as far as organizations, it makes a lot of sense.
Thank you.
I'm going to bring in we got started a little early. I'm going to bring in my partner in crime, Claire.
Hello, Claire.
And
Hello,
she's
Simon.
Where are you right now, Claire?
Well, the right side of the pond for Simon. Assuming he's in the UK.
I am in the UK. Which part of the UK are you in, by the way?
I'm down in deepest, darkest Devon, southwest.
Devon. I'm deepest, darkest Kent. So I'm Burmarsh, in a little swamp hidden in the middle of nowhere.
Yeah, well, mine's the hilly equivalent.
Excellent. Well,
very wet, hilly, and dark.
Well, with climate change, you will at least be above water whilst we're underneath it. But there we are.
Thank you. I did join. Sorry to interrupt you. I feel like you're in full.
No, I mean, that's what's great about this software is I can leave you backstage and then bring you in. I didn't want to interrupt Simon, but I want to keep you here. Feel free to chime in and ask questions and be part of the conversation. We're recording separate streams here, so I can chop it up and do whatever we need. But I wanted to get back to the tea and commodities and Wardley map and, bridge the analogy for some of our users of cup. You're talking about infrastructure, you're talking about the teacup, you're talking about the kettle, things that are commodities. Amazon S3, maybe Amazon the infrastructure, but the way you stitch it together really nicely is ways of getting at the politics in it, which the people part, the commodities part, but are there politics involved in tea, like there is in technology?
There's politics pretty much involved in everything. I mean, when I even map out, so you can map out physical activities, practices, data, knowledge. I do a lot of cultural mapping as well, so even ethical values. And the process of change always creates inertia, and it always ends up with politics of one form or another. So there are a lot of politics in mapping. And you mentioned cloud, so we won't run away from that. We'll go to that subject. So back in 2005 is when I started mapping. I stumbled upon this way of mapping, which I thought was useful for me. And I hoped it might be useful for others who hadn't done an MBA, because obviously you learnt the proper way to do it at an MBA school, and I was too cheap and I'd never been there. And it took me years to discover that wasn't the case. And so I mapped out my own business, and we're an online photo service. Well, we had 16 different lines of business, and so we start off with the users. What do they need? They wanted photo storage, image manipulation. Okay, what did that require? It required a website where you could upload photos and change things, and that required a runtime operating system, and underneath that was compute and data center, and all the way down to power. So we could map out our lines of business, and one of the first lessons we learned was the maps are dynamic, so that all the components are constantly moving or evolving as due to supply and demand competition. And so it was quite interesting back in 2005, because we could see that compute was very much late product. And so, we could anticipate, look, someone's going to turn this into a utility. Now, in order to turn it into a utility, you've got to have what I called CAST, the concept of the thing provided as a utility. So computers a product, computers a utility. Well, we'd had that since Donald Michaels back in the 1960s. So the concept was there. You've got to have attitude. So people have got to be really, really annoyed with the current way of providing it. And people were getting fed up with the expense of computing. I just want to compute for a little bit, but I had to go and buy and wait 6 months or 3 months or whatever for a server to. It was just annoying. It's got to be suitable, so widespread, well-defined enough, and the technology has got to exist. And friends of mine, Ian and Simon, had done Zen, and we were using Zen ourselves. We'd virtualized our own environment, and so. I could see from the maps that it was likely somebody was going to play a utility game. And I actually thought it was going to be Google. I didn't realize it was going to be next year with Amazon EC2. And it was actually a friend of mine, Ben Black, who proposed the idea of EC2 to Jeff Bezos back in 2003, 2004. Chris Pinkham and others then built it in South Africa as a standalone service, because Jesse was the master of disaster for Amazon's infrastructure, wouldn't allow this EC2 nonsense anywhere near their data centers. But the other lessons you learn, of course, is as things evolve and they shift, say, from product to utility, we have inertia because of pre-existing practices, existing capital and all that sort of stuff. And then because that inertia exists, there comes ways of exploiting it, manipulating it, and there's always politics involved in overcoming it. And then you learn more patterns. We knew as soon as things evolved, we'd start to get co-evolution of practice. We didn't know that, 5 years, 6 years later or whatever, Andy and Patrick would call those new practices DevOps, but we knew there'd be some new practices, and we knew there'd be new things appearing on top. So you can often say a lot about what's going to happen, but not when. Or you can say when something's going to happen and we're going to get a new practice, but not what, as in the details about the practice. And so you find it's a bit like, turns out the disruption everybody loves disruption theory, and you get Lepore and Christensen used to have an argument over whether it was predictive or not. Well, it turns out there's two different forms. There's a predictive disruption, or predictable, such as product to utility substitution, and then there's non-predictable. You don't know which way it's going to go, which is product to product substitution. So, like Christensen said that Nokia would win against Apple, and he was wrong, not because he was daft, but because it was unpredictable. But this sort of stuff falls out once you start looking at the context.
Yeah, super important stuff. And I would say my experience in the cloud at that phase, I didn't have the Wardley map. I didn't have the wider awareness. I was running SAP North American events at the time, and I was able to rapidly innovate with EC2 and S3 to scale for events, which are very hard to do and very costly with infrastructure. And I bought into that this was going to radically change my IT, which it did as an IT director at the time, and it's going to save me money. And I believe that. I actually believe that. And I was having a conversation with a young gentleman the other day that was telling me AI agents don't have to take vacations, and they're going to save us money. And I just had this moment. So what would you tell a young person like me in 2008, or a young person right now that's thinking this is going to save us money when there's these other things happening?
Okay. Oh, there's so many different things to unpack here. In terms of, but we'll stick with the we'll go with the myths one, because you've opened that door. So one of the things back in the early days of cloud, so I used maps to map out the environment. I could see how practices were changing. I was running strategy for a company called Canonical. They provide Ubuntu. So we use the maps to work out where to invest and where to target. So when I first arrived at Canonical, people were like, what are you here for? To bring you into the cloud. This was 2008. And a lot of people were like, well, that's just a fad. No, it's not. And use the maps to explain why and where we would target. And we spent, about $500,000, 18 months. We went from 3% of the operating system to about 70% of all cloud. So we managed to really take the space because we knew where to target. It's a bit like territorial maps. You can use the landscape as a force multiplier. Okay. So one of the things that you learn with maps is there are numerous repeating patterns. And so the most basic are what I call climatic patterns. They're like the economic rules of the game. Everything evolves. You will have inertia. There will be co-evolution of practice. And then you get these other patterns, which are universally useful principles called doctrine, and then gameplay. Now, if I just stick with the climatic patterns, you get rules like Jevons paradox. So William Stanley Jevons he wrote a paper called The Coal Question. I've actually got a copy behind me. And what happened is they made steam engines more efficient. And because they made steam engines more efficient, and this was back in the 1870s, something like that, it was a long time ago, people thought, well, use less coal. And in fact, coal went up. And the coal went up because we made steam engines more efficient. We found new uses for steam engines. So in the very early days of cloud, people would come along to me and say, oh, cloud's going to reduce our IT budget. Not a chance, because you're competing against others. Okay. We've already established that cloud was a shift of product to utility. So yes, it's about efficiency, but it will create new practices, which will give you speed, and new things, which will give you new sources of value. And you're in competition with others. Now, you might think, you adopt cloud and nobody will take advantage, create new stuff. Sure, then you'll save money. But what will happen is one of your competitors will go, oh, look, we've got extra resource. We can do some of these new things, new value. Now your customers are looking at your company going, oh, but they give that. You don't. So now you're under pressure to give these new services as well. So what happens is the amount of stuff you do goes through the roof. So people would say to me, cloud was going to reduce IT budgets. I said, no, you're going to end up doing more. And the next thing they'd say, oh, we can get rid of our sysadmins. It was just like, oh, God, here we go. All right. So we had 2,000 physical servers, large enterprise, 2008. And I would say that's going up to somewhere, probably maybe 50,000 virtual machines. And people would go, oh, that's just nonsense. Now, today, that's not nonsense. Okay. But back then it was like, oh, total nonsense. You're going up to 50,000, much more complicated, much more, and in some respects, complex environment, but more complicated. And you're going to have to somehow manage that. You're going to need just as many sysadmins, but with different skill sets, slightly altered. And so what happened is a whole bunch of execs tried to get rid of their sysadmins, and then they hired them back as DevOps engineers or SREs. It just means sysadmin with a different skill set. So the first thing is you don't save money. The second, you don't get rid of people. The third one is because you're building higher order systems and it's getting ever more complicated, the amount of energy that you're going to use is going to go up continuously. And you can see with progress over time. I did this for the Royal Society back in 2013, demonstrated this. So you end up using more energy. So the claims are always, and the other claim is just for startups. I remember it was clearing the air on cloud. And one of the big consultancy firms wrote this in 2009, that it was just for startups. No, of course it never was. And that's known as the Red Queen effect, because you're competing, it just takes one other enterprise to adopt and you have to. So what you get are usual myths just for startups. Get rid of people. We're going to save money. It's going to cost us less energy. And that's just generally nonsense. So we're in the large language model, GPT space. I don't like the word AI because AI is a massive field. And mostly when people talk about AI, they actually mean large language model GPTs. There are lots of other parts to AI which are useful. But this is the bit which everybody gets excited about. Yes, your software engineers are going to be using it for coding, but your code base for a large enterprise is going from 30 million to probably 1 billion lines of code. Just purely Red Queen effect in competition with others, the amount of new features you're going to produce. So you're going to need software engineers using large language models, GPTs, just to keep up with the total, the complexity and the complicatedness of what our systems are going to become. Yes, we've had a whole bunch of execs saying we're getting rid of software engineers, like Klarna saying we're getting rid of people. Klarna, of course, are now rapidly hiring them back. So yes, software engineers are gone. We're going to have people called agentic herders, AI wranglers, and humans AI integrators, or so. Software engineers with some other skill sets. Okay, but we just will pretend that they're not software engineers. Energy consumption is going up through the roof. Perfectly normal. IT budget, you're not going to save a penny. You're just going to end up doing more stuff. So it's no different. Yeah. Sorry.
I wish I had known this back in the day. I didn't know it, and I wish people who don't understand that, best of luck now.
We're going to do it.
Anything you want to add on, Claire?
I was going to say it's like the one that so many people say we will save money by doing it faster. And I go, well, no, you'll just be able to. You'll spend the same. You just, in theory, might deliver some more features, but your discretionary investment is still likely. You're not going to be able to say that doing that automation or implementing that tech will save you money in IT change. It's never happened, and I absolutely believe too that this sugar hit that people feel they're going to get from doing something with AI agents is somehow going to save them some money, like as in actually reduce headcount. Complete myth.
You say sugar hit. I love this because when I go back to 2007, 2008, the sugar hit that you got from having a server up and running within 5 seconds, rather than sitting down and having to fill out a purchase order and maybe it turn up 3 months later, was just enormous. It was just so exciting. So between 2006 and 2008, it was just like, wow. And so, yes, I absolutely, you get huge adrenaline rush from being able to do things. And then unfortunately, you do get people very excited, not thinking about what the implications of this are. And so they do come up with these wonderful statements that I only need one person to do all our work. We can get rid of all the rest. Yeah, you're in competition with others. They're going to do more stuff. You're going to need those people.
Yep, they're going to be doing different stuff.
Of course.
When did any, I mean, and the examples are all about, for the people that think of it as kind of process automation. It's like, how many workflow automation systems and projects do you need to prove that exactly that point? They rarely actually remove FTE out of an organization. They just do different stuff.
Yep.
Hopefully more value add. But I think there's some, I mean, the whole Wardley map opportunity to show this is this, the sugar hit to the true productization kind of lens. I think it's a very, very powerful way of bringing that.
That's where I'm going next with this. And Claire and I connected. We've been doing Wardley maps as part of what we're building and doing. That's kind of led to me reaching out to you. But I'm really big with APIs and landscape mapping. APIs are my hustle, my game, and making things visible. How do you make systems visible, the resources you have, how things work, the events? But what does LLMs and GPT do to the visibility spectrum on a Wardley map? As far as, I mean, I just can't, there's so much noise, I can't see anything anymore. I could with APIs, and that was getting crazy. Okay.
So when you look at a Wardley map, at the bottom is the evolution axis, Genesis custom product to commodity. And then there's a dotted line, usually is the y-axis. Which sometimes says value chain, sometimes says visibility, etc. It doesn't exist. All right. The chain of needs is on the map itself, and I only put it there just to say that when you look at a chain of needs, to the users at the top, the things directly connected to them, so high up, are visible. Like your cup of tea is very visible to your consumer, but the power to heat the kettle, to make the hot water, to make the tea, to make the cup of tea is actually not very, very visible to the end user. It's far removed. It's essential. It's part of the chain, but it's far removed. Okay, so in terms of visibility and invisibility, there's no real formal y-axis because you could have many chains at the same time. I'm doing a whole bunch of stuff on mapping out things like healthcare, education, space at the moment. I've got 3 separate groups mapping out space, and so it's useful just to think about the fact that you've got a chain. Things at the top are more visible to things they're closely connected to. Things far removed are less visible. Okay, so we've got a couple of things on APIs here, and then we'll get on to large language models as well. APIs is interesting. The reason I have a particular interest in that subject is I wrote something called the Innovate, Leverage, Commoditize Model back in 2005. And there's a book by AWS, its second ever, as in its own book, as in its own people created, called Reaching Cloud Velocity, written by Thomas Blood et al. And it was... it has 17 pages of my mapping in there, including the ILC model. And the ILC model is very simple. You take a product, you turn it into a utility. You expose it as an API. Then you get everybody else to build on top of it. Everybody else building on top acts as your free research and development department. Now you have to build them, okay, because they're using your service. So you can mine that billing data to spot what's growing and what's becoming interesting. So you mine your own billing data, and you discover, 90% of building kit internet is not going anywhere. 10% doing big data, it's growing. So you come out with a big data as a service thing. Let's give these names. We go product, to utility, we'll say compute, we'll call it EC2, people build on top. So we do big data as a service, we call it elastic map reduce. Now, what will happen is everybody cheers because they've got new things they can build with, except for the people who you've eaten their industry. They were like, oh my God, now this particular model, innovate, leverage, commoditize. Your rate of research depends upon the size of your ecosystem, because that's your free research and development lab. Your rate of customer focus now depends on the size of the ecosystem, because you're mining metadata to spot what's important. And your efficiency depends on scales, economies of scale. So it's the size of the ecosystem as well. So innovation, customer focus, and efficiency all increase with the size of the ecosystem. And this is where using APIs can be extremely powerful. You start to see loads of people say, we're going to build something as an API. Only do it once it's suitable to be a utility. Make sure you mine the metadata, the billing data, and exploit it. Otherwise, you're missing the point. They are fundamentally future sensing engines, very powerful tools. So in the past, people say you could do one of those three things. You could do innovate, customer focus, efficiency. You can do all three simultaneously. You've been able to do this for 20 years when I wrote the model. So you're seeing these games also being played in the large language model space. And the signals that you get that it's being played is that groups become highly innovative. They have conferences where people grumble that they've eaten our business model because they're harvesting the metadata to spot future patterns. And you can probably list the companies that, hang on, they seem to be doing this as well, providing new services built around their ecosystem by harvesting the ecosystem. It's fairly standard. All right. So that's the basic in terms of AIs, in terms of ILC model, and in terms of some of the games going on large language models. Your general question, however, was how large language models have sucked all the oxygen out of the room. As in, AI is an entire field with lots of extremely useful bits, and people have got suddenly unbelievably overhyped and overexcited by large language models and GPTs, to the point of people are talking about, by tomorrow, we're going to have AGI and all this sort of stuff created through the medium of a large language model. I've got to say it's very familiar to Web 1.0 and the noise that we got, and then the massive correction in the market. I mean, I think people have got very much run away with themselves. Yes, this stuff is important. Yes, it's incredibly important. I think some of the claims are if you ask me when AGI is occurring, I will tell you the same answer that I said about 5 years ago, which is 30 to 50 years from now. We're still a long, long way away. I think we're barking up the wrong tree. Do I find these models useful? Yes, I use them daily, but they are coherence engines, not truth engines. So they create very coherent sounding, looking code and arguments, but it's not necessarily truth and the right argument. And I see this all the time when I'm using them, which is why whenever I use them to look at a problem space that I'm not an expert in, the first thing I have to do is go and find somebody who is an expert in that space. And even when I am using them, I have to really, the number of errors, the assumptions made, and everything else, they're useful first drafts. There we are. That's the nicest way I can say it. So, but yes, they've sucked all the oxygen out because the VCs have piled in, and everybody's really excited, and everybody's got carried away, and they've basically started thinking them as like they're human.
Yeah, it's an interesting era, and there's similar to cloud. I'd like to even go up one more level. Cloud's up there. It was a useful abstraction until it stopped being useful in some areas, and people were using cloud in ways that I don't think were beneficial. But my wife is a specialist in education technology, and she wrote a book on the early coming out of World War II, a lot of the compute and a lot of the money, and around the space race in Sputnik, up till Sputnik, so World War II to Sputnik, and Dwight D. Eisenhower spent a lot of money on Sputnik and threw money at this because the Russian were gonna beat us in this game. And he actually knew, she did the research and went through, he actually knew that the Russians didn't have their shit together. Excuse me, I probably shouldn't cuss on our podcast, but but he said, you know what? This money needs to be spent. It's going to do other things geopolitically, and so there's a lot of people say we're going to be left behind if we don't do this. And at a U.S. level, at a UK, at an EU, China's going to have our lunch. So, what are the pros and cons of AI at that level, or LLMs, GPTs at that level?
Okay, so fascinating question. So I'm going to talk. I'll answer this question through. I'm going to start by discussing vibe coding. So one of the things I love doing is vibe coding, which is I build systems without ever looking at the code. Okay, and never for production, only for prototypes. And I built one particular system, and this was about a year ago. So I created a specification. I used the specification architectural diagrams and used an agentic swarm to start building this thing. And I got it to build me a testing engine. And I was really excited because as I'm having this conversation with the system, it's adding new tests. And I could run the testing engine, see what was succeeding in the system. If it was failing, copy the logs, of course, and give it to the swarm, and it would fix it. And what happened was after about 6 hours, I started to get suspicious. And so I broke the rule of vibe coding. I looked at the code, okay? And what I found was it hadn't built me a testing engine. It built me a simulation of a testing engine. So every test wasn't actually a test. It was a frequency that this function would fail. And if it failed, what is the error message likely to be? And so it was running this. And so creating these logs, which full of like reasonable looking error messages, which I thought, we're doing proper test driven development here. And we're not. We're doing an entire simulation of it. And I only saw that because I looked at the code. Now, whenever we build a system, we often talk about, we'll have our specification architectural diagram, but those are just wishes and beliefs. The actual choices, the actual decisions, the actual architecture is expressed in the code itself, not the diagrams. Which is why when you actually look at the underlying architecture of systems, they barely ever match the diagrams because they're very, very different things. So when you hand that responsibility over to another system, it is making those choices, those decisions for you. It is, regardless of the diagram you give it or specification, it ultimately is making the choice of what is within that system. And so one of the big architectural questions we have to decide today, not right now, but for any organization, is when you are building a system, where do you value humans in the decision-making process? And so this is why I'll often map a system. And some parts I'll say, well, vibe code the prototypes. We can use an agentic swarm over here. Over here, we're going to have to use software engineering plus some AI. And then maybe some bits we'll outsource because we don't really care about that. And so that's one of the big questions that you have to ask. But there's another challenging bit which gets us onto this national level. Because when you look at what's changing in the environment, our tool is changing in terms of we're going from, Visual Studios or whatever to co-pilots. Our language is changing. We're going from non-deterministic language to non-deterministic prompts. And our medium is changing. So we're going from just text, code as text, to code as images, can be all sorts of things. And that medium changes how we have conversations about things. And so you see this within any engineering department. The whiteboard, where the architectural diagram is, that's one medium where we're talking about the same problem that we talk about on the screen, but that's a different medium. And on the whiteboard, we tend to talk about objects, relationships, context, and on the screen, it's syntax, rules, and styles. So why does this matter? Well, tools, medium, and language are how you reason about the space around you. And if somebody else controls that, it's a bit like somebody controlling the printing press, the written word, and the medium being paper. If they control that, they control how you reason about the world around you. And so one of the huge dangers of, and not really talked about, of large language models is when you get them to build systems for you, they are making the decisions, okay? When you are using them, they are controlling the frame in which you can reason about a space. And if that is all controlled by someone else, then whatever values they have about the world are the values that are going to end up in whatever you create. And so the way to think about large language models is they're a bit like Hollywood. They're a bit like every other form of non-kinetic warfare. They're a way of embedding the values of one group or one collective into wider collectives. And there's this lovely paper that was done in 2023, which shows human to GPT responses versus cultural difference between the people and the US. And, you know, there's a certain part of the world, which is quite close to the US, and there's the rest of the world which has different values. Well, if you are using this stuff to build your systems, it's going to be embedding US values into everything you build. And that may be okay. It's a bit like choosing to vibe code or Agentics. You might go, yeah, we're cool with that. But it should be something we should be conscious about. Does that make sense? That was an awful lot. Did that?
No, that's so spot on. It's so perfect. I mean, it's why I see, Elon Musk bought Twitter. It's why Larry Ellison's interested in TikTok. It's why, Jeff Bezos is interested in the Washington Post. And, I think these aren't new tactics or new things. We just have them at a scale and level of money that's.
Well, Elon Musk, many things I don't like about Elon Musk, but I think his honesty about Grok. He's not hiding the fact that he's going to have it trained so it represents his worldview. Yeah. Okay. And people say, the trolley problem. Trolley coming along, you can kill 5 people, 1 person. Okay. Well, hopefully you kill the one. What if the one person is a gold member, as in has some digital subscription service, whatever, to it's really important? Well, hopefully you just killed the one person still. Well, what if you're not writing the application, but you handed that responsibility to a large language model? Well, the large language model is making that decision, and that decision will be based upon the values the large language model is trained with. And that may not be your values. And if you're not thinking about those things, probably should be.
Yeah, it's I've done a lot of consulting with enterprises, and I work for the Obama administration, government agencies, and you could tell which agency had kind of outsourced their soul to the Deloittes and the others of the world, and which had maintained their internal capacity to do things and actually maintain their databases. And so I went around doing the WSDL gathering. So who has the WSDLs for all the SOAP services? And it was some agencies, it was all Deloitte. It was all the consultancy had all of the keys to the kingdom, where others had catalogs and other things. And so you really see this just feels like outsourcing of our capacity at another level that I never even thought possible.
Outsourcing our capacity to reason. So yes, I've seen it. People outsource their infrastructure, and then they go, "Okay, we want to bring it back in house. We better get a network diagram." And the vendor goes, "No, that's our intellectual property." What our network diagram? so you have these terrible sort of moments. Well, literally, we're outsourcing ability to reason, and not only does that create others, it creates problems because we don't. So one of the things we don't do in the education system enough of is teach critical thinking. It's one of the critical areas we should invest in. It's interesting when you look at China's AI program, and people talk about they're teaching primary school kids AI. Yeah, but they're teaching them as part of the critical thinking syllabus. Because back in 2018, I think it was 2016, Ministry of Education identified critical thinking as a key or core competency of the future, which is quite ironical because you can't challenge the state. But anyway, so all of the AI stuff is being taught in terms of kids are learning how to spot misinformation, how to question it, how to challenge it. But in the West, when we tend to be teaching, we're teaching people to use this stuff, not challenge it. And we don't seem to be doing enough of the critical thinking. So I do get a little bit worried where we're going.
That warms my heart. My wife will be very happy to see that. That's her fight. So thank you for that. Bringing it back down to just a simpler level for folks. I mean, one of the things social media is kind of, you mentioned Twitter and Elon Musk, and social media is in an interesting state. And one of the things, Claire and I were doing this Wardley map exercise, and then I was watching how you're using LinkedIn. And I'm really fascinated how people can use LinkedIn in ways to cut through the noise and you're clearly not a bot. You're clearly not an agent. Can you talk to how you use LinkedIn?
Oh, gosh. How do I use LinkedIn? Well, first of all, I was using, I'll start with, I was using Twitter X all the time. And mostly I was using it as a vehicle for, I would have conversations with people. And then I'd create these, and I'd done this for about 10 years, these me and X conversations. Most of which is about me refining concepts and ideas and bringing together little strands of different conversations together into a whole. So Twitter X for me was very much a place of thinking out loud. And that's how I used it. But unfortunately, the changes to the environment meant it increasingly became a beer hall. Increasingly became a place you just went to have a fight, which was, was not the point. It just the atmosphere changed, so at one point it just seemed like people would soldier on trying to, but they would get hit by some of the most ridiculous arguments and just piled on by people. It just became, I found it unpleasant. And so I looked around other places to use, and I just tried a few things on LinkedIn, and I started just putting posts on there, having conversations on there, doing exactly what I was doing on Twitter X beforehand. Sometimes I'll do long posts on Medium. I'm writing some stuff with Tudor Gerber on rewilding software engineering at the moment. I just use it as I used to use Twitter X, nothing special. I find it a friendlier environment. I find that it's less like a beer hall. You get a lot more more interesting discussion. Yes, there's bots. There's bots everywhere. I mean, what was it? About 70. I saw some ridiculous figure about what percentage of internet content is now bots. And it's like ridiculous figure. I don't know if it's true or not. It doesn't matter. Because most of the stuff is about thinking out loud anyway. But I find it more friendly. So what's my secret sauce? I don't know if I have a secret sauce. That's all I can say.
I just like your exploration. I think it reflects, I think, what I try to use technology for. Some days I'm unsure if I'm a bot or not. I get asked regularly, it's like, are you a bot? I'm like, I don't know. I struggle with that. I don't know, maybe. But one last quick one. What gives you hope in this time? I mean, not just tech, but politics, what gives you hope right now?
What gives me hope? I always have hope. I always I think the human spirit is, there are always moments and times where things don't seem to be going right and all the rest of it. And then great things and wonderful things happen, and the right people appear, and the environment changes, and history has these sorts of cycles of good and bad. And when we look at it through a past lens or something along those lines. So I'm always positive about people. I'm not necessarily positive about individuals. There's certain things, certain individuals which, and I suppose at the heart of this, you're making me think here. Yes. So at the heart of this is, you've got a society which needs people. Okay. And societies, we define our societies through values. So what you've got is society has values, and it has people. And government needs people to vote for it. But governments also need a market to trade stuff and give money to do stuff. And people need a market as well to buy, sell stuff from. Now, markets need property, because they need trade, they need property. And property requires a value of exclusion. It's my property, not your property, or your property, not my property. Now, people need another value, which is inclusion. So there's always this balancing act between the level of exclusion we have in society and the level of inclusion. We need exclusion for market forces, but we need inclusion for opportunity, etc. And so there's always a balancing act. And fundamentally, one of the many roles of government is getting that balance right between the levels of exclusion and the levels of inclusion. I think we've probably gone a little bit way too far on the exclusion and not enough on the inclusion side. But those aren't permanent states of affairs. I mean, they change with time. They change with people. They change with ideas. So what gives me the hope? The past does. Because we waned and toward inclusion, exclusion historically in the past. I'm sure we will again in the future.
Yeah, I like that. I don't care about APIs or code or any of that. APIs, for me, have always been a vehicle about storytelling and what matters to people and the connections and that exist in there. I actually don't care about APIs, but I'm a storyteller, and stories are what influence people, and stories are what matter. And so that's the only thing that I stick to. So.